looking at this from our tank problem, I can see that it's first order linear. So first order, meaning that I have a first derivative, not a second derivative or a third derivative. It's linear because S, which is my dependent variable, wherever it appears in the problem, only has an invisible exponent of 1, meaning it's linear with respect to S. So I want to start solving this first by getting it into our standard form. And our standard form, I need to add this piece over because I need something times S equals something. So when I add this over, I'm going to have 6 over 150 plus 4t, and this something that will be left is the 10. In terms of our first order linear differential equations, that's our P, that's our Q, and our next step is to find our integrating factor. Our integrating factor, or mu, is going to come from e to the integral of P dt. And what variable goes with here is just whatever letter is here. So if this had been with respect to x, that would be the integral of P dx. But because we're with respect to t, it'll be the integral of P dt. So thinking about that integral, we're going to be integrating 6 over 150 plus 4t dt. We can do a u substitution on this. This is one of the ones that has a number over a linear term. So I know that that linear term on the bottom is going to give us a natural log of that linear term, and then we'll need to divide by the 4 to correct for what would happen if we did chain rule. If that's still a little bit uncomfortable for you, we can go ahead and write out the u substitution. And if u is 150 plus 4t, that's going to make du 4 dt, or 1/4 of du will be equal to dt. That's going to turn this into 1/4, and I can move my 6 out in front as well. So let's make that a 6/4, the integral 1 over u du, or 6/4 natural log of u. And finally, that 6/4 I can call 3/2. So 3/2 natural log of 150 plus 4t. This is not my integrating factor. Our integrating factor is e raised to whatever's here. So 3/2 natural log of 150 plus 4t. So if you haven't done any of these first order linear problems yet, especially with the tank problems, we often end up with natural logs. And we really would like to simplify this as much as possible before moving on. So the trick is to use our power of exponents with natural logs. So that 3/2 out in front, I'm going to bring inside as an exponent so that my e and my natural log can cancel out, which is going to make mu 150 plus 4t raised to an exponent of 3/2. All of that work was just so that we can move forward with our first order linear piece over here. So I definitely wish I had a bigger board. Our next step is to multiply every term in our equation by our integrating factor. So I've got 150 plus 4t raised to the 3/2 power times s prime plus 150 plus 4t raised to the 3/2 power times 6 over 150 plus 4t times s. And because I'm running out of room, I'm going to erase this. Are there questions about how I found my integrating factor before it goes away? Going once. going twice. It's equals 10 times 150 plus 4t to the 3 halves power. On the left-hand side, the whole point of using this first order linear integrating factors method is that what we see on this side should be a product rule. And it should always work out to be the product of that integrating factor, or mu, times s. And if you want to prove this to yourself, let's do a quick product rule. So this piece looks like we left the first alone and took the derivative of s. So the hope would be that this right here looks like the derivative of 150 plus 4t to the 3 halves. Well, if I had 150 plus 4t to the 3 halves, I'd bring down that 3 halves, subtract 1 from the exponent. So that was going to give me a 3 halves times all of this stuff to the 1/2 power. Well, secretly, these two are also going to give me a 1/2 plus 4t to the 1/2 power. So the only question is the 6 right? So I'd have that 3 halves multiplied down in front, but then chain rule would pop out another 4. So I'd have 3 halves times 4, which would give me 12. Divided by 2, I'd get 6. So it worked. Question in the chat about, do you actually have to show the product rule? No. If you've done it correctly, it will always work out to be the integrating factor times s or y or n or whatever your variable is. Okay. On this side, I'm going to undo that product rule by just writing it without the prime. And on the right-hand side, I'm going to undo this derivative by taking the antiderivative, or the integral. So I've got 150 plus 4t to the 3 halves times s is equal to 10 times the integral of 150 plus 4t to the 3 halves dt. This is definitely a case where I'm going to want a u substitution, and if you can do that u substitution in your head, that's totally fine. I'm going to go ahead and write it out. So u is 150 plus 4t, which makes du for dt, which makes 1/4 du equal to dt. So when I rewrite this, I'm going to end up with 10/4 the integral of u to the 3 halves du. Integrating that, I'm going to run out of space here. I can squeeze it in. 10/4 is the same as 5 halves. So I've got 5 halves. When I add 1 to the exponent, that's going to be an exponent of 5 halves. So I'll have u to the 5 halves, and u was 150 plus 4t. And then I would divide by 5 halves, which means it's gone. Plus a constant. Now, we still have on this side the 150 plus 4t to the 3 halves times s, and we'd want to get the s by itself. So getting that s all by itself would look like the 150 plus 4t to the, 5 halves power plus c, and then each of those terms would be divided by the 150 plus 4t to the 3 halves power. And we could simplify that if we wanted to. I would say the only last step that we probably should do is to take into account our initial condition. And that initial condition was that S was 40 when T was equal to 0. So to solve for that C, I would let S be equal to 40, plug in 0 for T. So that's gonna give me 150 to the 5 halves over 150 to the 3 halves. But if I simplify those exponents, 5 halves minus 3 halves is 2 halves, or just 1. So really this simplifies to 150 plus 4t to the 1 power. I'm plugging in 0 for t, that would be 150. And then over here, I've got c over, plugging in 0 for t, I'd have 150 to the 3 halves power. I think I didn't give us a particularly nice number, but 150 to the 3 halves power is 1837. So 150 to the 3 halves power is approximately that, and you can rearrange that to solve for C. I will leave that to you to do.